To find the relative humidity, we need two calorimeters with polished outer surfaces, sufficient amount of ice chips, a stirrer, a sheet of glass, two thermometers calibrated from 0 to 50 centigrades, and two stands. So this is the list of materials and apparatus required. Then you have to arrange those as shown by this experimental setup. As you can see, these are the two polished calorimeters standing on two stands. Then you have these two thermometers, the stirrer and this glass of sheet should be in front of both calorimeters. Thermometer T1 is immersed in water and the ice chips will be added to this calorimeter only. Then we have the thermometer T2. It is inside the calorimeter and it will take temperature measurements of the surrounding. The purpose of T1 thermometer is to measure the dew point of the room, and the purpose of T2 is to take the room temperature. So once you have measured the room temperature and the dew point, you have to get the saturated vapor pressure values from a table for those temperatures. Then simply you have to substitute them in this equation. You can find the relative humidity. This P0 is the saturated water vapor pressure at dew point. This P is the saturated water vapor pressure at the room temperature. In brief, this is what you have to do to find the relative humidity. Then let's consider how to continue this experiment step by step. First, you have to wipe out the outer surfaces of the calorimeters till they get a shiny surface. Then half of one of the calorimeters should be filled with water. Then place these thermometers T1 and T2 using stands. After that, you have to place this glass of sheet in front of the calorimeters. The purpose of the glass of sheet is to prevent the exhaling air being incident on the calorimeter surfaces. Normally, the exhaling air has high humidity, so it could tarnish the outer surface of the calorimeters. So you have to observe the calorimeter surfaces standing behind and through the glass. Now that the experimental setup is complete, you have to start adding ice chips into these calorimeters. While observing you have to add ice chips one after the other. Put one ice chip and stir till it gets completely dissolved. Then put the other ice chip. While adding ice chips, you have to observe the outer surface of this calorimeter compared to the other one. After a while, you will notice the tarnishing of this calorimeter surface. Note down the temperature from this thermometer. Let's say that is T1. Tarnishing of the calorimeter surface happens due to depositing of dew. Normally, that causes below the dew point. So the temperature reading at the moment is T1. Then stop adding ice and keep continuing stirring and let the temperature to increase. The temperature increases because the surrounding air is at a higher temperature than the temperature of the calorimeter. So the calorimeter absorbs heat from the surrounding and the temperature keeps increasing. After a while, you will notice the outer surface of the calorimeter regain the shine. At the moment regaining the shine, take the temperature reading. Let's say the temperature reading is theta 2. So this temperature caused above the dew point because the outer surface of the calorimeter regained its shine after evaporation of the dew. So that causes above the dew point. So let's say theta naught. So this is the dew point temperature, theta naught. So theta 1 is below the dew point. Theta 2 is above the dew point. So in this case, you have to measure the dew point. To get the dew point, if you add these two values and divide by 2, you will get a good estimate for the dew point. So you have to add these values and divide by 2. So this is a good estimate for the dew point, theta naught. So now that we know the dew point, we have to measure the room temperature. Room temperature can easily be measured by this thermometer. The air inside this thermometer is at the room temperature. So you have to simply take the reading of this thermometer. That is the room temperature. So we know the dew point and the room temperature. Then what we have to do is to get the related pressure values for the dew point and the room temperature. And we have this equation. We can find the relative humidity. Then let's consider how to do it using an example. For the example, let's say the dew point is 20 centigrades and the room temperature is 25 centigrades. So as you can see by the table, you will see the saturated water vapor pressure at 20 centigrade is 0.02339 bar. And at 25 centigrades, saturated vapor pressure is 0.03169 bars. So those values simply can be substituted in this equation. So it is P naught is 0.02339 and room temperature vapor pressure is 0.03169 multiplied by 100%. You will get an approximate value of about 73.8%. So this is how you can calculate or find experimentally a value for the